Hello, my name is Barry Hickey, and in this lesson I'm going to talk to you about the principles of the ellipse. The ellipse is a conic, which means it's a curved shape, and before we get started into the how it's formed or how to draw it, I'm just going to make a few quick notes of words that by the end of the lesson we want to be able to define and understand why they are linked to the ellipse. So the first word is the major axis. So we want to know what the major axis is and what its relationship to the ellipse is. Next is the minor axis. After that we have the focal points. Next is the vertex. And finally we have the cutting plane. So by the end of this short video, hopefully we will be able to point out why each of these 5 words are linked to the ellipse, and we'll be able to define each of them as well. Here's a cone I have already drawn. This is where we begin our learning on the ellipse. An ellipse is when a cone or cylinder An ellipse is formed when a cone or cylinder is cut at an angle to its base. So the cut isn't parallel to its base. So the cut, if you follow the cursor, goes this way. So I have put in one of these cuts already into this. I've made a plane that cuts this cone at an angle to its base. So if I just hide the cone on top of the plane, we can see this shape here. This shape is no longer circular like it would be if the cutting plane had been horizontal or parallel to its base. So once the cutting plane is at an angle, the shape formed is an ellipse. So if I put down here and we see this, I have heavied in, and in red we can see the shape that is formed on the surface when the cone is cut. So now what I'm going to get you to do is in pairs talk and discuss where you might have seen ellipses before in everyday life, and there will be a class discussion in 2 minutes. Okay, now that we know how an ellipse is formed, we're going to learn the different parts of it and their names. So here's an ellipse I have sketched already, and I'm just going to start labeling it. So the first labels we'll put on it are the major and the minor axis. So if we come here, this is the major axis. So the major axis is the longest point on the ellipse. So it's that goes through the center. So it's the longest point on the ellipse, the longest distance across the ellipse that passes through the center. Longest point line on the ellipse that passes through the center point. So that's the major axis. So if we think about it now, if that's the major axis, the minor axis must be the opposite to this. So the minor axis is the shortest line, across the ellipse through the center. Okay, so the next thing we want to learn about is the focal point. So the position of the focal point is got by getting the length of half the major axis. So if I stick my compass on the center point and my pen on the end of the major axis, I get half the major axis. And the focal point is found when half of the major axis is swung from the end of the minor axis. So if I swing an arc here, and where this arc cuts the major axis, this dotted red center line, this point is the focal point. And in an ellipse, there are two focal points because it is one continuous shape. So this point right here, I'm going to call it F1 and F2. So F1 is the focal point on the left, focal point, and F2 is a focal point. Focal points are extremely important with regard to ellipses, as they are how the shape of an ellipse, how long it is, or how close to circular it is determined by how far apart they are. So from the focal point we'll move on to a focal chord. So if you remember what a chord is from doing circles, a chord is a line that cuts the curve in two places but doesn't have to be going through the center. So if we think of what a focal chord would be, a focal chord is one of these lines that passes through one of the focal points. So this blue line is a focal chord. Okay, and similarly, a line going through F2 at any angle once it passes through the focal point is also a focal chord. So from the focal chord, we're going to move on to the vertex. So if we look at this, there could be 4 points that there are 4 points that the axis cut on the ellipse, but the vertices are where the major axis cuts the ellipse. So here is vertex 1, and here on the other end of the major axis is vertex 2. So far we've found out the major axis, the minor axis, the focal points, and how to find these focal points. I'm just going to draw it in. So the focal point is found by swinging an arc from the top of the minor axis, and this radius length is equal to half the major axis. So the next thing we're just going to touch on is drawing a tangent, or tangents to an ellipse, and the terminology that follows it. So here is my point of contact. So this is where the tangent touches the ellipse. What we need to do is draw two lines from focal 1 to the point of contact, and focal point 2 to the point of contact. We need to bisect this angle in here that is created when between the two focal points and the point of contact. So if I get my compass and do the angle bisection construction, I will find the middle of that angle, and I'll extend it out through the point of contact. This line is called the normal. So I'm not going to go into how to draw a tangent just yet, but we'll just remember how to find the normal and the name the normal itself, because it would be important to learn how to draw a tangent. Now that we know the different parts of an ellipse, we're going to attempt to draft one and draw an ellipse properly. So here I have my major and minor axis. So these are the correct length. So the method I'm going to use to draw the ellipse is the auxiliary circles method. So I'll write that down here. Auxiliary circles. So we're going to talk about auxiliary circles. So the auxiliary circles of an ellipse are the circles that are made with half the length of the major axis as one radius. So this is the major auxiliary circle, and the minor auxiliary circle is made in the same way, using the minor axis as the radius. Both these circles are concentric, with center at the the center of the ellipse and the intersection of the major and minor axis. So the next thing we want to do is to draw lines that cut both these circles, just at any angle. I'm going to use my 30 degree set square, and I'm going to draw a line at 30 degrees this way, at 60 degrees, 60 degrees this way, and 30 degrees here. So this will give me points that it cuts both the major auxiliary circle and the minor auxiliary circle. So to find the point that lies on the ellipse, it has something to do with both these points. So what we have to do is bring a vertical line from where it cuts the major auxiliary circle. So we bring this down, and now we're going to bring a horizontal line from where it cuts the minor auxiliary circle. The intersection of these two points, or these two lines, will give us a point, and this point lies on the ellipse. So if we recap down here, so it's a vertical line that comes from the major auxiliary circle and a horizontal line that comes from the minor auxiliary circle. So there's those two intersecting again, and this point here will lie on the curve. So if I just finish this by doing the same with the other points, we'll be able to draw our ellipse. So all of these intersections of the blue lines are points that lie on the ellipse. So all we have to do now is join up these points. And remember, the longest point on, or the longest line on the ellipse will be the major axis. So both these points are in the ellipse, and the opposite of this, both these points on the minor axis are on the ellipse. So I'm going to get my pencil and join up these points, and we should start to see an ellipse being formed. I just get a heavier marker to show the shape of the ellipse. So this is how we draw an ellipse using the auxiliary circles method. So to recap, we had our major and our minor axis. We found our major and our minor auxiliary circles by getting radius of half of the major axis for the major auxiliary circle and swinging an arc from the center point. And same, we got a radius of half of the minor axis for the minor auxiliary circle and swung an arc right around to get our minor auxiliary circle. We found our lines, or we drew in our lines that cut both the minor and major axis all around the auxiliary circles. We dropped a vertical from where, or rose a vertical. We drew a vertical line from where it hit the major auxiliary circle, and we drew a horizontal line where it hit the minor auxiliary circle. Where these two points intersected, or the point of intersection of these two lines, lay on the curve of the ellipse. So that's how we drew the ellipse using the auxiliary circles method. Now, just to recap, I'm going to go back to this sheet, and in pairs or groups of 3, we're going to discuss the points and the meaning of each of these 5 headings. So the major axis, the minor axis, the focal points, the vertex, and the cutting plane. So we want to know what each one is, and also why it is in the ellipse or related to ellipse.